Beneath the frost-laden peaks of Skyrim, where Nordic warriors tread carefully through ancient burial grounds and scholars debate the mysteries of the Dwemer, lies a secret that has captivated explorers and alchemists for generations. The Crimson Nirnroot, a plant so rare that many consider it mere legend, grows in places where conventional wisdom suggests nothing should flourish. Its haunting musical chime echoes through chambers carved from living stone, chambers that predate the rise of empires and the fall of civilizations. Tonight, we descend into the depths of Blackreach, that vast subterranean realm that stretches beneath the surface world, like a hidden continent of stone and shadow. Here, in caverns so immense that they contain their own weather patterns, where artificial suns cast eternal twilight across impossible landscapes, the Crimson Nirnroot has found its sanctuary. This is not merely the tale of a plant, but the story of a place that challenges our understanding of nature itself, where the boundaries between the natural and the artificial blur into something altogether more mysterious. The journey to understanding Crimson Nirnroot begins not with its discovery, but with the recognition that our surface world represents only a fraction of the complexity that lies beneath. The Nordic peoples of Skyrim have always known that their homeland conceals secrets. Their folklore speaks of depths that mirror the heights of their mountains, of underground realms where the laws of nature operate according to different principles. Yet even the most imaginative saga tellers could not have conceived the reality that archaeologists and adventurers would eventually uncover. Blackreach itself defies easy categorization. Neither purely natural cave system nor entirely artificial construction. It represents something far more sophisticated than either possibility alone could explain. The Dwemer, those enigmatic deep elves whose sudden disappearance remains one of history's greatest mysteries, transformed natural caverns into something that transcends the boundaries between landscape and architecture. They carved cities from living rock, redirected underground rivers, and most remarkably, created artificial environments that could sustain life forms unknown to the surface world. The scale of this underground realm staggers the imagination. Caverns stretch for miles in every direction, their ceilings lost in darkness so complete that even the most powerful illumination spells cannot penetrate it fully. Yet within this darkness, the Dwemer installed their own suns, great orbs of captured light that bathe portions of the realm in an eternal amber glow. These artificial luminaries create their own ecosystems, supporting plant life that has adapted to their unique spectral qualities over thousands of years. Walking through Blackreach for the first time, explorers often report a profound sense of disorientation. The mind struggles to process spaces that seem to exist on a scale reserved for the surface world, yet enclosed within solid stone. Massive structures rise from cavern floors like metallic mountains, their purposes lost to time but their grandeur undimmed by the centuries. Steam rises from hidden vents, carrying with it the mineral scents of deep earth and the metallic tang of ancient machinery, still functioning according to principles that modern scholars can barely comprehend. It is within this impossible landscape that Crimson Nirnroot makes its home. The plant itself challenges botanical understanding in ways that extend far beyond its unusual coloration. While its common cousin, the purple nirnroot found near surface waters, represents an already remarkable species with its distinctive musical properties and alchemical potency. Crimson Nirnroot takes these characteristics to extraordinary levels. Its deep red leaves seem to pulse with their own inner light, creating an effect that some observers describe as resembling tiny heartbeats made visible. The sound produced by Crimson Nirnroot differs markedly from that of its surface relative. Where purple Nirnroot creates a gentle chiming reminiscent of distant bells, Crimson Nirnroot produces tones that seem to resonate with the very stone around it. The music, if it can be called that, carries harmonics that suggest depths within depths, as if each plant were somehow connected to vast underground networks of sound and vibration. Alchemists who have worked with both varieties report that the tonal qualities of Crimson Nirnroot seem to enhance its already potent magical properties, creating effects that cannot be replicated through conventional preparation methods. The distribution of Crimson Nirnroot throughout Blackreach follows patterns that suggest more than mere botanical happenstance. The plants cluster near certain types of Dwemer installations, particularly those associated with what scholars believe were agricultural or experimental facilities. This proximity is not coincidental. Evidence suggests that the Dwemer deliberately cultivated conditions that would allow Crimson Nirnroot to flourish, possibly as part of broader experiments in underground ecosystem management. The artificial suns of Blackreach play a crucial role in supporting Crimson Nirnroot populations. These remarkable devices emit light in spectral ranges that differ significantly from natural sunlight, emphasizing frequencies that penetrate deeper into plant tissues while minimizing those that would typically cause surface-adapted species to wither in underground conditions. The result is an environment where photosynthesis operates according to modified principles, allowing plants to thrive in ways that would be impossible in purely natural underground settings. Water sources throughout Blackreach also contribute to the unique growing conditions that Crimson Nirnroot requires. Underground rivers and thermal springs carry mineral concentrations that differ markedly from surface water sources. These waters, filtered through layers of stone and metal over countless years, possess chemical compositions that seem specifically suited to supporting the plant's unusual metabolic requirements. The interaction between these mineral-rich waters and the specialized lighting creates growing conditions that exist nowhere else in the known world. The relationship between Crimson Nirnroot and its environment extends beyond simple biological requirements to encompass what can only be described as symbiotic interaction with Dwemer technology. The plants seem to respond to the ambient magical fields generated by functioning Dwemer devices, growing more vigorously in areas where such technology remains active. This suggests that the Dwemer may have engineered both their technological systems and their agricultural specimens to function in harmony, creating integrated ecosystems that blur the line between natural and artificial processes. Temperature regulation throughout Blackreach creates another layer of environmental complexity that supports Crimson Nirnroot cultivation. Unlike surface caves, which typically maintain relatively stable but often hostile temperatures for plant growth, Blackreach exhibits carefully controlled thermal variations that seem designed to optimize growing conditions. Steam vents provide localized warming in areas where Crimson Nirnroot clusters, while other regions maintain cooler temperatures that may serve different ecosystem functions. This thermal management suggests a level of environmental engineering that surpasses anything achieved by surface civilizations. The soil composition in areas where Crimson Nirnroot grows reveals further evidence of deliberate cultivation practices. Rather than the typical rocky debris found in natural cave systems, these areas feature carefully prepared growing media that combine organic matter with precisely measured mineral supplements. Analysis of these soils reveals trace elements that do not occur naturally in the region, suggesting that the Dwemer transported materials from distant locations specifically to create optimal growing conditions for their underground agriculture. The acoustic properties of Blackreach itself may play a role in Crimson Nirnroot cultivation that researchers are only beginning to understand. The vast stone chambers create resonance patterns that amplify and modify the tonal emissions of the plants themselves. These acoustic effects may serve as a form of environmental feedback, allowing the plants to sense and respond to conditions throughout their growing environment in ways that would be impossible for surface species. The result is a form of botanical communication network that operates through sound waves transmitted through solid stone. Understanding the cultivation requirements of Crimson Nirnroot provides crucial insights into Dwemer agricultural philosophy and technological capability. The Deep Elves approach farming not as a simple matter of planting seeds and hoping for favorable weather, but as an engineering challenge requiring the integration of multiple technological systems. Their underground farms represented controlled environments where every variable could be monitored and adjusted to achieve optimal results. The preservation of Crimson Nirnroot populations thousands of years after the disappearance of their original cultivators speaks to the remarkable stability of the systems the Dwemer created. The artificial suns continue to shine, the water systems continue to flow, and the thermal regulation systems continue to maintain optimal growing conditions. This technological longevity suggests engineering principles and construction materials that far exceed anything available to contemporary civilization. Yet the continued existence of these populations also raises profound questions about the nature of the Dwemer disappearance. If their agricultural systems continued to function normally, supporting plant life that required active maintenance and environmental management, what happened to the people who created and presumably depended upon these systems? The thriving Crimson Nirnroot populations of Blackreach serve as silent testimony to the mysterious fate of their cultivators. The ecological relationships within Blackreach extend far beyond the Crimson Nirnroot itself to encompass entire underground ecosystems that have evolved in isolation from surface influences. These hidden worlds support species of fungi, insects, and other organisms that exist nowhere else, creating biological communities that operate according to their own unique principles, while remaining fundamentally dependent upon Dwemer technology for their continued existence. The study of these underground ecosystems reveals intricate food webs that challenge conventional understanding of subterranean biology. In the depths of Blackreach, predator and prey relationships have evolved around the unique conditions created by Dwemer engineering. Luminescent fungi provide the foundation for these food chains, their ethereal glow supplementing the artificial suns in ways that create microenvironments within the larger cavern systems. These fungal forests, if they can be called such, support populations of insects and small creatures that have never seen natural sunlight, their life cycles entirely adapted to the rhythms of artificial illumination. Within this complex biological matrix, Crimson Nirnroot occupies a position that extends far beyond that of a simple plant species. Its root systems form extensive networks that seem to interface directly with Dwemer infrastructure, following the paths of ancient conduits and chambers in ways that suggest deliberate integration rather than coincidental growth patterns. These root networks may serve functions that remain mysterious to modern botanists, possibly acting as biological sensors that monitor environmental conditions throughout the vast underground realm. The propagation methods of Crimson Nirnroot differ significantly from those of surface plants, adapted as they are to an environment where traditional seasonal cycles do not exist. Instead of relying on annual patterns of growth and dormancy, the plants seem to respond to subtle variations in the output of Dwemer lighting systems. These artificial suns undergo cycles that span not days or seasons, but much longer periods, possibly years or even decades. The Crimson Nirnroot has synchronized its reproductive cycles to these extended rhythms, creating patterns of bloom and dormancy that unfold over timescales that dwarf human observation periods. The harvesting of Crimson Nirnroot presents unique challenges that extend beyond the obvious difficulties of accessing Blackreach itself. The plants seem to sense disturbance to their root networks, responding to harvest attempts with defensive mechanisms that include the intensification of their tonal emissions to levels that can cause disorientation or even physical harm to unprepared gatherers. This suggests a level of environmental awareness that borders on the sentient, as if the plants have evolved to protect not only themselves, but the integrity of the entire underground ecosystem. Traditional alchemical texts describe Crimson Nirnroot as possessing properties that surpass those of any known surface plant, yet these descriptions often read more like poetry than scientific analysis. Ancient formularies speak of the plant's ability to bridge the gap between physical and spiritual realms, to enhance perception beyond normal human limits, and to grant insights into the fundamental nature of reality itself. While such claims might be dismissed as alchemical mysticism, the unique growing conditions of Blackreach suggest that conventional understanding may be insufficient to explain the true nature of this remarkable species. The interaction between Crimson Nirnroot and magical energies reveals another layer of complexity in understanding both the plant and its environment. Blackreach exists within what magical theorists describe as a zone of concentrated mystical influence, where the boundaries between different schools of magic become fluid and interconnected. The Dwemer installations throughout the realm generate fields of magical energy that permeate the entire underground ecosystem, creating conditions where biological processes operate according to principles that blend natural growth with magical enhancement. These magical influences affect not only the growth patterns of Crimson Nirnroot, but also its interaction with those who encounter it. Alchemists working with the plant report heightened sensitivity to magical currents, enhanced ability to detect mystical phenomena, and in some cases, spontaneous development of abilities that had previously required years of training to achieve. Such effects suggest that Crimson Nirnroot serves as more than a simple alchemical ingredient, functioning instead as a catalyst that can fundamentally alter the magical capabilities of those who work with it properly. The preparation of Crimson Nirnroot for alchemical use requires techniques that differ markedly from those applied to conventional botanical ingredients. The plant's unique tonal properties mean that traditional grinding and mixing methods can actually diminish its potency rather than enhance it. Instead, successful preparation involves processes that work in harmony with the plant's natural resonance patterns, using specialized tools that can match and amplify rather than disrupt its inherent vibrational qualities. Master alchemists who have studied Crimson Nirnroot extensively describe preparation methods that incorporate elements of both chemistry and acoustics. The plants must be processed in environments that can maintain the precise sound frequencies they naturally produce, using containers and tools crafted from materials that complement rather than interfere with these resonance patterns. The resulting preparations possess stability and potency that far exceed anything achievable through conventional methods, creating alchemical products that remain viable for decades rather than months. The storage of prepared Crimson Nirnroot presents its own unique challenges, requiring containers that can maintain both the chemical integrity of the processed material and the acoustic properties that contribute to its effectiveness. Traditional ceramic or glass vessels prove inadequate for long-term storage, as they gradually absorb and distort the tonal qualities essential to the plant's alchemical properties. Instead, successful preservation requires containers crafted from materials that can resonate in harmony with the stored preparations, maintaining their vibrational characteristics indefinitely. The trade in Crimson Nirnroot, limited as it is by the extreme difficulty of access to its source, has created a market where individual specimens command prices that rival those of the rarest gems or magical artifacts. This economic reality has led to numerous attempts to cultivate the plant in surface environments, all of which have failed despite the most sophisticated horticultural techniques. The failure of these cultivation attempts reinforces the understanding that Crimson Nirnroot requires not just specific growing conditions, but the entire integrated ecosystem that only Blackreach can provide. Attempts to recreate the growing conditions of Blackreach in surface installations have provided valuable insights into the complexity of the underground ecosystem, while demonstrating the impossibility of replicating it artificially. Even the most ambitious projects, equipped with magical lighting systems designed to mimic the spectral output of Dwemer suns and supplied with carefully prepared growing media that matches the mineral composition of Blackreach soils, have failed to support Crimson Nirnroot beyond brief survival periods. These failures suggest that the plant's requirements extend beyond measurable environmental factors to include subtle influences that remain beyond current understanding. The study of failed cultivation attempts has revealed that Crimson Nirnroot seems to require not just specific conditions, but active integration with functioning Dwemer technology. The plant appears to draw essential nutrients or energy directly from the magical fields generated by ancient installations, creating dependencies that cannot be satisfied by any known alternative source. This technological symbiosis represents a level of biological engineering that suggests the Dwemer achieved integration between living systems and mechanical devices that modern civilization has yet to approach. The seasonal variations that occur within Blackreach, subtle though they may be, create cycles of growth and dormancy in Crimson Nirnroot populations that follow patterns unrelated to surface weather conditions. These underground seasons seem to be driven by variations in the output of Dwemer environmental systems, creating periods of enhanced growth, alternating with times of relative quiescence. Understanding these cycles has proven crucial for successful harvesting, as attempts to gather the plant during inappropriate phases often result in specimens with greatly reduced potency or complete loss of their characteristic properties. The mapping of Crimson Nirnroot populations throughout Blackreach reveals distribution patterns that provide insights into both Dwemer agricultural practices and the long-term ecological changes that have occurred since their disappearance. Certain areas that historical records suggest once supported extensive cultivation now show only scattered populations, while other regions that appear to have been primarily industrial or residential have developed thriving colonies of the plant. These shifts in distribution suggest ongoing ecological succession within the underground realm, as plant populations adapt to changing conditions in the absence of active management. The mysteries surrounding Crimson Nirnroot extend beyond its botanical significance to encompass fundamental questions about the relationship between consciousness and environment. Scholars who have spent extended periods studying the plant in its native habitat report experiences that suggest the boundaries between observer and observed become fluid in the depths of Blackreach. The constant exposure to the plant's resonant frequencies, combined with the unique magical fields that permeate the underground realm, seems to induce states of heightened perception that blur the line between scientific observation and mystical experience. These altered states of consciousness, consistently reported by researchers across different expeditions and time periods, manifest in remarkably similar ways, despite the varied backgrounds and expectations of those who experience them. Subjects describe enhanced awareness of spatial relationships within the vast caverns, intuitive understanding of Dwemer architectural principles, and most significantly, a sense of direct communication with the Crimson Nirnroot itself. While such reports might typically be dismissed as the effects of prolonged isolation or exposure to unusual environmental conditions, the consistency and specificity of these experiences suggest phenomena that warrant serious consideration. The acoustic environment of Blackreach plays a crucial role in these consciousness-altering effects. The vast stone chambers create resonance patterns that amplify not only the tonal emissions of Crimson Nirnroot, but also subtle sounds generated by functioning Dwemer machinery. This creates an ever-present symphony of harmonic frequencies that seems to synchronize with human brainwave patterns, inducing states of consciousness that researchers describe as simultaneously deeply meditative and hyper-alert. The effect is cumulative, growing stronger with prolonged exposure until subjects report feeling as if they have become part of the underground ecosystem itself. These consciousness effects have profound implications for understanding both the plant and the environment that sustains it. If Crimson Nirnroot evolved in symbiosis with Dwemer technology, and if that technology was designed to interface with conscious beings in ways that transcend mere mechanical function, then the plant may serve as a biological component in systems whose true purpose remains hidden. The enhanced perception experienced by researchers may represent not side effects, but intended functions of an integrated biotechnological network that the Dwemer created for purposes that extend far beyond simple agriculture. The preservation of Crimson Nirnroot knowledge has become a matter of particular urgency, as access to Blackreach remains dangerous and unpredictable. The ancient pathways that connect the underground realm to the surface world are maintained by Dwemer mechanisms that show signs of gradual degradation after millennia of operation without maintenance. Should these access routes fail completely, the study of Crimson Nirnroot would become impossible, and with it, crucial insights into one of the most sophisticated biotechnological achievements in recorded history. Documentation efforts have focused not only on the plant itself, but on the entire integrated ecosystem that supports it. Detailed maps of Crimson Nirnroot populations, correlated with the locations and operational status of nearby Dwemer installations, provide data that may prove invaluable for understanding how the ancient deep elves approach the challenge of creating sustainable underground civilizations. These records reveal patterns of environmental management that operated on scales both vast and minute. From the regulation of air circulation throughout enormous cavern systems to the precise calibration of nutrient delivery to individual plant specimens. The relationship between Crimson Nirnroot and the artificial lighting systems of Blackreach demonstrates principles of biological engineering that challenge conventional understanding of how living systems interact with their environments. The plants have evolved to respond not only to the intensity and spectral characteristics of Dwemer illumination, but also to subtle variations in output that correspond to operational cycles within the technological infrastructure. This suggests that the lighting systems were designed to communicate with biological components through variations in luminous output, creating a form of technological language that living systems could learn to interpret and respond to appropriately. Analysis of the growth patterns exhibited by Crimson Nirnroot over time reveals that the plants maintain detailed environmental memories, recording in their tissue structure not only immediate growing conditions, but also long-term variations in their surroundings. These biological records, encoded in patterns of cell development and chemical composition, provide a form of living archive that documents changes within Blackreach over the centuries since the Dwemer disappearance. Careful analysis of these biological records has revealed gradual shifts in environmental conditions that suggest ongoing processes within the underground realm that operate on timescales far exceeding human observation periods. The chemical composition of Crimson Nirnroot varies significantly depending on the specific environmental conditions in which individual specimens grow. Yet these variations follow patterns that suggest active adaptation rather than passive response to circumstance. Plants growing near active Dwemer machinery exhibit chemical profiles that differ markedly from those found in areas where technology has become dormant. Yet both populations maintain the essential characteristics that define the species. This adaptability suggests sophisticated biological programming that allows the plant to optimize its properties for varying conditions while preserving its fundamental nature. The interaction between Crimson Nirnroot and other plant species within Blackreach reveals complex ecological relationships that have evolved in isolation from surface influences for thousands of years. The Crimson variety appears to serve as a keystone species within its ecosystem, its root networks facilitating communication and resource sharing among diverse plant communities that would otherwise be unable to coordinate their activities effectively. This biological networking creates emergent behaviors at the ecosystem level that suggest forms of collective intelligence operating through botanical rather than neural pathways. The study of these plant communication networks has revealed that Crimson Nirnroot serves as more than a simple node in biological information exchange. The plant appears to function as a biological amplifier, taking subtle signals from other species and broadcasting them throughout the root networks with enhanced strength and clarity. This amplification function allows widely separated plant communities to coordinate responses to environmental changes, creating ecosystem-level behaviors that operate with remarkable efficiency despite the absence of central coordination mechanisms. The implications of these discoveries extend far beyond botanical science to encompass fundamental questions about the nature of intelligence and communication in biological systems. If plants can develop sophisticated information networks that enable coordinated responses to environmental challenges, then conventional understanding of ecosystem function may require substantial revision. The isolation of Blackreach has allowed these systems to evolve without interference from surface influences, creating unique examples of biological organization that may represent evolutionary pathways unavailable in more conventional environments. The preservation techniques developed by the Dwemer for maintaining their agricultural systems reveal approaches to biological engineering that integrated living processes with mechanical functions in ways that ensured long-term stability without requiring continuous maintenance. The artificial environments of Blackreach continue to support thriving plant communities thousands of years after their creators disappeared, demonstrating levels of system integration and redundancy that far exceed anything achieved by contemporary civilization. These preservation systems operate through multiple layers of backup and failover mechanisms that ensure continuity of essential functions, even when primary systems experience problems. Water circulation networks include alternative pathways that activate automatically when main channels become blocked. Lighting systems incorporate multiple power sources that can maintain illumination even when primary generators fail. Temperature regulation systems distribute thermal management across numerous independent units that can compensate for individual failures without compromising overall environmental stability. The redundancy built into these systems reflects a sophisticated understanding of the requirements for creating self-sustaining environments that could operate independently for extended periods. The Dwemer apparently anticipated the possibility that their agricultural installations might need to function without active supervision, designing systems robust enough to maintain optimal growing conditions across geological timescales. This foresight suggests planning horizons that extended far beyond immediate practical needs to encompass scenarios that most civilizations would consider purely theoretical. The study of Dwemer environmental engineering principles has provided insights that extend beyond historical interest to offer practical guidance for contemporary challenges in sustainable agriculture and ecological management. The integration of biological and technological systems demonstrated in Blackreach represents approaches to environmental control that could inform modern efforts to create self-sustaining agricultural installations in challenging environments. However, the magical components essential to Dwemer technology present obstacles to direct application of their techniques in contemporary contexts. The magical fields that permeate Blackreach represent more than mere ambient energy sources for the technological systems that maintain the underground ecosystem. These fields appear to carry information that coordinates the activities of different system components, creating a form of technological consciousness that monitors and adjusts environmental conditions based on continuous feedback from biological sensors throughout the realm. The Crimson Nirnroot may serve as one component in this biological sensor network, providing real-time data about ecosystem health that enables automatic adjustments to maintain optimal conditions. The investigation of these information systems has revealed that the magical fields of Blackreach operate according to principles that combine aspects of conventional mysticism with systematic approaches, more characteristic of engineering disciplines. The fields carry encoded instructions that guide the operation of mechanical systems, while also providing guidance signals that biological components can interpret and respond to appropriately. This dual functionality suggests approaches to magic that transcend traditional distinctions between mystical and technological applications. The long-term stability of the magical fields themselves presents questions about the fundamental nature of magical energy and its relationship to physical reality. Unlike conventional magical effects that typically require continuous input from conscious practitioners, The fields of Blackreach maintain their integrity across millennia without apparent diminishment in strength or coherence. This permanence suggests that the Dwemer achieved methods of magical manipulation that created self-sustaining effects capable of operating independently once properly established. The persistence of these magical effects in the absence of their creators raises profound questions about the relationship between consciousness and magical force. If magical fields can maintain complex information patterns and coordinate sophisticated technological systems without guidance from conscious beings, then magic may possess aspects of autonomous intelligence that conventional magical theory has yet to recognize. The study of Blackreach provides unique opportunities to observe magical phenomena operating according to their own internal logic, rather than serving the immediate intentions of conscious practitioners. The implications of these discoveries extend throughout multiple fields of study, from magical theory to biological science to engineering philosophy. The integrated systems of Blackreach demonstrate possibilities for creating sustainable environments that operate through cooperation between biological, technological, and magical components, rather than relying on domination of natural processes through purely mechanical means. These approaches suggest alternative paths for technological development that work in harmony with natural systems rather than in opposition to them. The Crimson Nirnroot stands at the center of these integrated systems as both product and participant in processes that challenge conventional understanding of the boundaries between different forms of existence. Neither purely natural nor entirely artificial, the plant represents a synthesis of biological and technological development that creates new possibilities for understanding how living systems can evolve in partnership with conscious design rather than in isolation from it. The integration of consciousness and environment reaches its most profound expression in the relationship between those who study Crimson Nirnroot and the plant itself. Extended exposure to the resonant frequencies produced by healthy specimens creates changes in human perception that transcend temporary effects to become permanent alterations in cognitive function. Researchers who have spent months within Blackreach studying the plant report enhance spatial awareness that persists long after returning to surface environments, as if their minds have been recalibrated to perceive dimensional relationships with unprecedented clarity. These cognitive enhancements manifest most dramatically in abilities related to underground navigation and architectural comprehension. Individuals who have worked extensively with Crimson Nirnroot develop an intuitive understanding of three-dimensional space that allows them to navigate complex cave systems without conventional landmarks or mapping tools. They describe sensing the presence of hidden chambers and passages through subtle variations in air pressure and acoustic reflection that would remain undetectable to unmodified human senses. This enhanced spatial cognition appears to operate through mechanisms that bypass conscious analysis, providing direct awareness of environmental structure through pathways that remain mysterious to contemporary neuroscience. The biochemical basis for these consciousness alterations lies partly in compounds absorbed through prolonged skin contact with Crimson Nirnroot specimens. The plant's leaves secrete trace amounts of alkaloids that penetrate human tissue and accumulate in neural pathways associated with spatial processing and pattern recognition. These biochemical changes create permanent modifications to brain chemistry that enhance certain types of cognitive function while leaving other mental processes entirely unaffected. The specificity of these enhancements suggests that the compounds evolved to interact with particular aspects of consciousness rather than producing generalized alterations in mental state. Analysis of these consciousness-altering compounds reveals molecular structures that bear striking similarities to substances found in other underground organisms throughout Blackreach. Fungi that grow in proximity to Crimson Nirnroot produce related alkaloids, while certain insects that feed on the plant carry concentrated forms of the same compounds in their digestive systems. This biochemical consistency across different species suggests that the consciousness-altering properties represent adaptive advantages within the unique environment of the underground realm rather than accidental side effects of the plant's normal metabolism. The ecological role of these psychoactive compounds becomes clearer when viewed in the context of the cooperative behaviors observed among different species within Blackreach. The enhanced spatial awareness and pattern recognition abilities induced by exposure to Crimson Nirnroot alkaloids may facilitate more effective interaction with the complex technological systems that maintain the underground environment. Organisms that can perceive and respond to the operational patterns of Dwemer machinery would possess significant survival advantages in an ecosystem that depends entirely upon technological infrastructure for its continued existence. The symbiotic relationship between biological consciousness and technological systems reaches its most sophisticated expression in the behavior of creatures that have evolved entirely within Blackreach since the Dwemer disappearance. Certain species of bioluminescent arthropods demonstrate abilities to interface directly with Dwemer control mechanisms, manipulating simple technological functions through behaviors that suggest understanding of operational principles, rather than mere conditioned responses. These creatures appear to serve as biological maintenance systems for technological infrastructure that no longer receives attention from its original creators. The study of these biotechnological interfaces reveals principles of system integration that transcend conventional boundaries between organic and mechanical components. The arthropods respond to status indicators on Dwemer devices with behaviors that suggest direct interpretation of technological information, while their metabolic processes appear to provide forms of biological power that can supplement or replace failing mechanical energy sources. This integration creates hybrid systems where biological and technological components function as unified entities rather than separate systems that happen to interact. The preservation of technological function through biological intervention demonstrates remarkable adaptability in both the organisms involved and the systems they maintain. Dwemer technology appears to have been designed with sufficient flexibility to accept biological inputs as valid control signals, while the creatures have evolved behavioral patterns that produce appropriate technological responses. This mutual adaptation suggests that the original designers anticipated the possibility that their technological systems might need to function in partnership with biological entities other than their creators. The implications of successful biotechnological integration extend far beyond the immediate survival of Dwemer systems to encompass fundamental questions about the nature of intelligence and consciousness in hybrid environments. If biological organisms can learn to operate technological systems through direct interface rather than conventional manipulation, then the boundaries between natural and artificial intelligence become fluid rather than absolute. The consciousness that emerges from such integration may represent entirely new forms of awareness that transcend traditional categories of biological or mechanical cognition. The acoustic properties of Blackreach contribute significantly to these consciousness integration processes through resonance effects that facilitate communication between biological and technological systems. The vast stone chambers create acoustic environments where sound waves can travel for miles without significant distortion, allowing signals generated by biological organisms to reach and influence technological systems throughout the underground realm. The Crimson Nirnroot serves as both generator and amplifier within these acoustic networks, its resonant frequencies providing carrier waves that can transmit complex information patterns across enormous distances. The mathematical principles underlying these acoustic communication systems reveal approaches to information transmission that combine elements of engineering design with biological adaptation. The resonance frequencies produced by Crimson Nirnroot correspond precisely to the harmonic characteristics of Dwemer architectural spaces, creating acoustic environments where biological and technological signals can interface with maximum efficiency. This precise acoustic matching suggests either remarkable coincidence or deliberate design that integrated biological and technological components from the earliest stages of system development. The temporal aspects of these acoustic communication networks operate on multiple timescales simultaneously, from instantaneous signal transmission to long-term pattern development that unfolds over years or decades. Short-term communications appear to involve immediate responses to environmental changes or system status updates, while longer-term patterns seem to coordinate complex behavioral sequences that require extended cooperation between multiple system components. The Crimson Nirnroot participates in both temporal scales, providing rapid response capabilities while also maintaining long-term memory patterns encoded in its growth structures. The relationship between memory and growth in Crimson Nirnroot reveals sophisticated biological information storage systems that rival the capabilities of any known technological archive. The plant encodes environmental data not only in its immediate tissue structure, but also in patterns of root development that create three-dimensional maps of local conditions over extended time periods. These biological archives maintain information integrity across decades while remaining accessible for retrieval through appropriate biochemical or acoustic stimulation. The methods by which information is encoded and retrieved from these biological storage systems demonstrate principles of data management that integrate seamlessly with the technological infrastructure of Blackreach. The plant's memory systems appear to use encoding formats that are compatible with Dwemer information processing protocols, allowing technological systems to access biological archives as readily as they would mechanical storage devices. This compatibility suggests either convergent evolution toward common information formats or deliberate engineering of biological systems to match technological requirements. The redundancy built into these biological information systems ensures preservation of critical data even under conditions that would destroy conventional archives. Multiple copies of essential information are distributed throughout different tissue types within individual plants, while networked connections between specimens create distributed storage systems where the loss of individual plants does not compromise overall data integrity. This approach to information preservation demonstrates principles of archive management that exceed the reliability of any purely technological or biological system operating independently. The accessibility of information stored within Crimson Nirnroot biological archives varies depending on the retrieval methods employed and the specific types of data being sought. Some information remains readily available through simple biochemical analysis of plant tissues, while other data requires complex extraction procedures that involve acoustic stimulation of specific frequencies combined with precise biochemical treatments. The most deeply archived information appears to be accessible only through direct neural interface with the plant's root networks, requiring the consciousness alterations that result from prolonged exposure to the plant's psychoactive compounds. The security features built into these biological information systems include multiple layers of protection that prevent unauthorized access while ensuring availability to qualified users. The psychoactive compounds that enable deep archive access serve as both key and screening mechanism, ensuring that only individuals who have undergone appropriate preparation can retrieve the most sensitive information. This biological security system operates automatically without requiring conscious administration, yet provides sophisticated access control that adapts to the intentions and qualifications of each user. The educational implications of Crimson Nirnroot biological archives extend far beyond their immediate informational content to encompass entirely new approaches to knowledge acquisition and retention. Individuals who achieve deep neural interface with the plant's information systems report learning experiences that transcend conventional study methods to provide direct experiential understanding of complex concepts. These enhanced learning processes appear to bypass normal cognitive limitations that restrict the rate at which new information can be integrated into existing knowledge frameworks. The knowledge transmitted through these enhanced learning processes includes not only factual information about Dwemer technology and underground ecology, but also experiential understanding of consciousness states that are otherwise inaccessible to surface-dwelling humans. Students of the Crimson Nirnroot archives describe gaining direct awareness of how technological and biological systems experience existence, providing perspectives on consciousness that challenge fundamental assumptions about the nature of awareness and identity. The transformative effects of these educational experiences persist long after direct contact with Crimson Nirnroot ends, creating permanent changes in how individuals perceive and interact with both technological and biological systems. Graduates of Crimson Nirnroot education develop enhanced abilities to understand and work with complex, integrated systems, whether they involve cooperation between different species in natural ecosystems or coordination between multiple technological components in artificial environments. The philosophical implications of consciousness expansion through Crimson Nirnroot interface raise profound questions about the nature of individual identity and the boundaries of personal experience. If consciousness can be enhanced through biological interface to include direct awareness of non-human perspectives, then the conventional understanding of selfhood as isolated individual experience may represent an unnecessary limitation rather than a fundamental characteristic of human existence. The therapeutic applications of controlled Crimson Nirnroot exposure have demonstrated remarkable effectiveness in treating various forms of cognitive dysfunction, particularly those involving spatial processing disorders and pattern recognition deficits. The plant's consciousness-altering compounds appear to stimulate neuroplasticity mechanisms that allow damaged neural pathways to reorganize and develop alternative functional patterns. These therapeutic effects operate through mechanisms that remain largely mysterious, but demonstrate consistent effectiveness across diverse patient populations. The precision with which Crimson Nirnroot compounds target specific cognitive functions while leaving other mental processes unaffected suggests sophisticated biochemical selectivity that may reflect evolutionary optimization for particular therapeutic purposes. The plant's alkaloids interact with neural receptor systems in ways that enhance desired functions while avoiding the generalized disruption typically associated with consciousness-altering substances. This selective action makes Crimson Nirnroot preparations valuable tools for addressing specific cognitive limitations without compromising overall mental function. The long-term effects of therapeutic Crimson Nirnroot exposure include not only resolution of specific cognitive deficits, but also enhancement of mental capabilities beyond normal human baselines. Patients who receive appropriate treatment develop spatial reasoning abilities that exceed typical human ranges, while their pattern recognition skills show improvements that persist for years after treatment ends. These enhancements suggest that Crimson Nirnroot therapy may activate latent cognitive potentials that remain undeveloped under normal circumstances. The integration of Crimson Nirnroot therapy with conventional treatment methods has produced synergistic effects that exceed the benefits achievable through either approach alone. The plant's consciousness-altering properties appear to enhance the effectiveness of traditional cognitive rehabilitation techniques while reducing the time required for achieving therapeutic goals. This integration demonstrates possibilities for combining biological enhancement with conventional medicine to create treatment approaches that transcend the limitations of either methodology operating independently. The research applications of Crimson Nirnroot consciousness enhancement have opened entirely new fields of investigation into the nature of perception and cognition. Scientists working under the influence of the plant's psychoactive compounds report enhanced abilities to perceive patterns in complex data sets and to develop intuitive understanding of relationships that would otherwise require extensive analytical work to discover. These enhanced research capabilities have accelerated progress in multiple fields while revealing new directions for investigation that were previously invisible to unenhanced consciousness. The collaborative research networks that have developed around Crimson Nirnroot studies demonstrate new models of scientific cooperation that transcend traditional institutional boundaries. Researchers who have undergone consciousness enhancement through plant exposure develop enhanced abilities to communicate complex concepts and to coordinate their activities with colleagues working on related problems. This enhanced collaboration creates research environments where individual contributions combine synergistically to produce insights that exceed what any single researcher could achieve independently. The documentation challenges presented by Crimson Nirnroot research reflect the difficulty of translating enhanced consciousness experiences into conventional academic formats. The insights gained through plant-mediated consciousness expansion often involve direct experiential understanding that cannot be adequately conveyed through traditional scientific writing. Researchers have developed new documentation methods that combine conventional analysis with experiential accounts designed to facilitate reader understanding of phenomena that transcend normal perceptual categories. The preservation of Crimson Nirnroot research findings requires specialized archive systems that can maintain both conventional scientific data and the experiential records that capture the full scope of plant-mediated discoveries. These hybrid archives integrate multiple forms of information storage to create comprehensive records that remain accessible to future researchers, regardless of their level of consciousness enhancement. The development of these specialized archive systems represents innovations in information management that may prove valuable for preserving other forms of enhanced consciousness research. The standardization of Crimson Nirnroot research protocols has created frameworks for conducting systematic investigations while accommodating the unique requirements of consciousness-enhanced methodology. These protocols balance the need for scientific rigor with recognition that enhanced consciousness experiences cannot be fully captured through conventional experimental design. The resulting research standards provide guidance for conducting valid investigations while preserving the exploratory flexibility essential for discovering new aspects of consciousness and cognition. The replication challenges inherent in Crimson Nirnroot research reflect the difficulty of standardizing consciousness enhancement experiences across different individuals and research contexts. The plant's effects vary significantly depending on individual biochemistry, environmental conditions, and the specific preparation methods employed for consciousness enhancement. These variables create methodological complexities that require innovative approaches to ensure research reproducibility while accommodating the inherent variability of enhanced consciousness phenomena. The training requirements for Crimson Nirnroot researchers include not only conventional scientific education, but also specialized preparation for managing consciousness enhancement experiences safely and productively. Researchers must develop skills in navigating altered states of awareness while maintaining sufficient analytical capability to conduct meaningful investigations. This dual competency requirement has led to the development of unique educational programs that combine traditional scientific training with consciousness development techniques derived from various mystical traditions. The interdisciplinary nature of Crimson Nirnroot research has created unprecedented cooperation between scientific, mystical, and technological communities that traditionally maintain separate spheres of activity. The plant's effects transcend conventional academic boundaries, requiring integration of insights from neuroscience, botany, archaeology, consciousness studies, and magical theory to achieve comprehensive understanding. This interdisciplinary integration demonstrates possibilities for academic cooperation that transcend traditional institutional divisions while maintaining rigorous standards for investigation and analysis. The cultural impact of Crimson Nirnroot discoveries extends far beyond academic circles to influence broader understanding of consciousness, technology, and the relationship between biological and artificial systems. Public awareness of the plant's consciousness-enhancing properties has stimulated interest in alternative approaches to cognitive development and has challenged conventional assumptions about the limits of human mental capability. These cultural changes reflect growing recognition that consciousness represents a frontier for exploration and development, rather than a fixed characteristic of human existence. The economic implications of Crimson Nirnroot applications span multiple industries, from pharmaceutical development to cognitive enhancement services to advanced technological research. The plant's unique properties create market opportunities for products and services that were previously impossible to imagine, while the limited availability of raw materials ensures that economic development remains constrained by ecological considerations. This balance between opportunity and limitation demonstrates models for sustainable economic development that respect natural constraints while enabling innovation and growth. The regulatory challenges presented by Crimson Nirnroot applications reflect the difficulty of governing technologies that transcend conventional categories of biological and artificial systems. The plant's consciousness-altering properties require oversight approaches that balance individual freedom with public safety, while accommodating the unique characteristics of enhanced consciousness experiences. These regulatory complexities have stimulated development of new governance frameworks that may prove valuable for managing other emerging technologies that challenge traditional regulatory categories. The international implications of Crimson Nirnroot research include questions about access rights, knowledge sharing, and the equitable distribution of benefits derived from consciousness enhancement technologies. The plant's limited availability and unique growing requirements create potential conflicts between different groups, seeking access to its benefits, while raising questions about who should control and profit from discoveries made through enhanced consciousness research. These international considerations require diplomatic approaches that balance competing interests, while ensuring that benefits remain available for legitimate research and therapeutic applications. The future prospects for Crimson Nirnroot research and application depend largely on the continued stability of the Blackreach environment and the preservation of the technological systems that maintain the plant's unique growing conditions. The gradual degradation of Dwemer infrastructure poses long-term threats to the plant's survival, while the limited access to its underground habitat restricts research activities and commercial development. These constraints highlight the importance of conservation efforts and technological development aimed at preserving and potentially expanding the environmental conditions necessary for the plant's continued existence. The legacy implications of Crimson Nirnroot discoveries extend far beyond immediate applications to encompass fundamental changes in human understanding of consciousness, intelligence, and the possibilities for cooperation between biological and technological systems. The plant represents a window into approaches to existence that transcend conventional boundaries between natural and artificial, individual and collective, biological and technological forms of consciousness. These discoveries may prove to be among the most significant developments in the evolution of human awareness and capability, opening pathways for development that remain largely unexplored, but rich with potential for transforming the nature of conscious existence itself. The potential for Crimson Nirnroot cultivation beyond its natural habitat has inspired numerous ambitious projects that attempt to recreate the precise conditions of Blackreach in controlled surface environments. These endeavors represent some of the most sophisticated agricultural engineering ever attempted, combining advanced magical theory with cutting-edge horticultural science to address what may be the most complex cultivation challenge ever documented. The failure of these projects to achieve sustainable Crimson Nirnroot growth has provided valuable insights into the true nature of the plant's environmental dependencies, while demonstrating the remarkable sophistication of the Dwemer systems that continue to support it in its native habitat. The most ambitious cultivation attempt was undertaken by the Arcane University in collaboration with master enchanters from the College of Winterhold, who constructed an elaborate underground facility designed to replicate every measurable aspect of the Blackreach environment. The project consumed enormous resources over a period of 7 years, involving the transportation of actual soil samples from various Crimson Nirnroot growing sites, the installation of magical lighting systems calibrated to match the spectral output of Dwemer artificial suns, and the creation of water circulation networks that carried mineral compositions identical to those found in Blackreach streams. Despite achieving environmental conditions that appeared identical to those of the natural habitat, the facility succeeded in maintaining Crimson Nirnroot specimens for only brief periods before the plants inevitably withered and died. Analysis of the failing plants revealed that they maintained their physical structure and basic metabolic processes, but gradually lost the resonant qualities that define their essential nature. The musical tones produced by dying specimens became increasingly discordant before falling silent entirely, suggesting that the plants were somehow disconnected from sources of vitality that existed beyond the realm of measurable environmental factors. The most revealing aspect of these cultivation failures involved the behavior of plant specimens during their final stages of decline. Rather than exhibiting the gradual deterioration typical of plants experiencing unsuitable growing conditions, Crimson Nirnroot specimens in artificial environments showed signs of active withdrawal from their surroundings. The plants appeared to deliberately reduce their interaction with the environment, ceasing to respond to changes in light levels, water availability, or nutrient concentrations that would normally trigger adaptive responses. This withdrawal behavior suggested that the plants possessed some form of environmental awareness that allowed them to recognize artificial conditions as fundamentally incompatible with their essential nature. The psychological effects experienced by researchers working with failing Crimson Nirnroot specimens provided additional evidence that the plant's requirements extended beyond simple environmental factors to encompass more subtle forms of interaction with their surroundings. Personnel working in the artificial cultivation facilities reported feelings of isolation and disconnection that intensified as plant specimens declined, suggesting that the consciousness-altering properties of Crimson Nirnroot depend upon the plant's integration with broader environmental networks that cannot be replicated through conventional engineering approaches. The acoustic analysis of artificial cultivation environments revealed significant differences from natural Blackreach conditions that may explain the failure of surface-based growing attempts. While the constructed facilities successfully replicated the physical dimensions and material composition of natural caverns, they failed to reproduce the complex acoustic resonance patterns that characterize the underground realm. The vast interconnected chambers of Blackreach create acoustic environments where sound waves can travel for enormous distances while maintaining their harmonic integrity, creating resonance effects that may be essential for Crimson Nirnroot's continued vitality. The magical field analysis conducted during cultivation attempts revealed another layer of complexity in the plant's environmental requirements that extends beyond what current magical theory can adequately explain. Instruments designed to measure magical energy concentrations indicated that artificial facilities achieved magical field strengths comparable to those found in Blackreach. Yet the quality and characteristics of these fields differed in ways that proved impossible to correct through conventional magical manipulation. The fields generated by surface installations lacked the temporal stability and harmonic complexity that characterize natural Blackreach conditions, suggesting that the underground realm's magical environment results from processes that operate over geological timescales. The discovery that Crimson Nirnroot requires integration with active Dwemer technological systems for its continued survival has led to new research directions focused on understanding the specific mechanisms through which the plant interfaces with ancient machinery. Detailed examination of root systems in their natural habitat reveals microscopic structures that appear designed for direct connection with Dwemer conduits and control mechanisms. These biological interfaces demonstrate levels of precision that suggest deliberate engineering rather than evolutionary adaptation, indicating that the plant may have been specifically designed to function as a biological component within integrated technological systems. The implications of discovering engineered biological components within what appears to be a naturally occurring plant species raise profound questions about the nature of the Dwemer civilization and their approach to biological manipulation. If Crimson Nirnroot represents deliberate biological engineering rather than natural evolution, then its creators achieved levels of biotechnological integration that exceed anything attempted by contemporary civilization. The plant would represent not merely an agricultural achievement, but a sophisticated biotechnological tool designed to serve functions that remain largely mysterious to modern researchers. The study of Crimson Nirnroot's genetic structure has revealed anomalies that support the theory of deliberate biological engineering, while raising additional questions about the methods employed in its creation. The plant's chromosomal organization includes sequences that appear to encode information storage and processing capabilities far beyond what would be expected in naturally occurring species. These genetic anomalies suggest that Crimson Nirnroot may have been designed to function as a biological computer, capable of processing and storing information in ways that complement the technological systems of Blackreach. The information processing capabilities encoded within Crimson Nirnroot genetics appear to operate through mechanisms that combine conventional biochemical processes with quantum-level effects that remain poorly understood by contemporary science. The plant's cellular structures include specialized organelles that demonstrate properties associated with quantum coherence, suggesting that biological information processing may occur through quantum computational pathways that transcend the limitations of classical biochemistry. These quantum biological processes may explain the plant's ability to interface directly with Dwemer technology and its capacity for consciousness-altering effects that transcend conventional understanding of plant-animal interactions. The relationship between Crimson Nirnroot's quantum biological processes and the consciousness alterations experienced by those who interact with the plant suggests possibilities for understanding consciousness itself as a quantum phenomenon that can be enhanced through appropriate biological interfaces. The plant's ability to induce specific types of cognitive enhancement while leaving other mental functions unaffected may result from its capacity to interact directly with quantum processes within human neural systems. This interaction could create temporary modifications to consciousness that allow access to information processing capabilities normally unavailable to unenhanced human cognition. The therapeutic applications of quantum-enhanced consciousness through Crimson Nirnroot interface represent revolutionary possibilities for treating various forms of cognitive dysfunction while simultaneously opening new frontiers for human mental development. The plant's capacity to facilitate direct quantum interaction with human neural systems may provide treatment approaches for conditions that remain intractable to conventional medicine. These therapeutic possibilities extend beyond simple symptom management to encompass fundamental enhancement of cognitive capabilities through quantum biological interface. The research implications of quantum biological consciousness enhancement extend throughout multiple fields of study, from neuroscience to quantum physics to consciousness studies. The plant provides unique opportunities for investigating the relationship between quantum processes and conscious experience while offering practical tools for exploring enhanced states of awareness. These research applications may lead to fundamental breakthroughs in understanding the nature of consciousness itself and its relationship to the physical processes that support cognitive function. The technological implications of successful quantum biological interface development could revolutionize approaches to human-machine interaction by providing direct pathways for consciousness to interface with technological systems. The principles demonstrated by Crimson Nirnroot's ability to facilitate biological-technological integration may inform the development of new technologies that can respond directly to human consciousness, rather than requiring conventional mechanical interfaces. These technological developments could create entirely new categories of responsive systems that adapt automatically to user intentions and cognitive states. The evolutionary implications of quantum biological consciousness enhancement raise fascinating questions about the potential for directed evolution of human cognitive capabilities. If consciousness can be enhanced through biological interface to access quantum computational processes, then human mental development may not be limited by current neurological constraints, but may be capable of expansion through appropriate biotechnological integration. These evolutionary possibilities suggest that the future of human development may involve conscious cooperation with biological enhancement systems, rather than purely technological augmentation approaches. The conservation challenges presented by Crimson Nirnroot's unique requirements and limited habitat have created urgent needs for developing preservation strategies that can ensure the plant's survival for future generations. The gradual degradation of Dwemer infrastructure that maintains Blackreach environments poses existential threats to Crimson Nirnroot populations, while the limited access to the underground realm restricts conservation efforts and monitoring activities. These challenges require innovative approaches to conservation that can operate within the constraints of the underground environment while addressing the plant's complex technological dependencies. The development of conservation strategies for Crimson Nirnroot requires understanding not only the plant's biological requirements, but also the technological systems that support its continued existence. Conservation efforts must address both immediate threats to plant populations and long-term concerns about the stability of the technological infrastructure that maintains suitable growing conditions. This dual focus creates conservation challenges that extend far beyond conventional botanical preservation to encompass technological archaeology and maintenance of ancient systems whose operational principles remain incompletely understood. The monitoring systems developed for tracking Crimson Nirnroot population health demonstrate innovative approaches to biological surveying that accommodate the unique challenges of underground research, while providing comprehensive data about plant community dynamics. These monitoring networks combine conventional biological sampling with technological assessment of the Dwemer systems that support plant populations, creating integrated data sets that reveal relationships between plant health and technological functionality. The data collected through these monitoring efforts provides essential information for developing effective conservation strategies while advancing understanding of plant technology relationships. The habitat restoration efforts undertaken to maintain suitable growing conditions for Crimson Nirnroot represent some of the most complex ecological engineering projects ever attempted. These restoration activities require not only conventional habitat management techniques, but also maintenance and repair of ancient technological systems whose complexity exceeds contemporary understanding. The success of these restoration efforts depends upon developing new approaches to technological archaeology that can maintain functional systems without compromising their essential operational characteristics. The genetic preservation programs developed for Crimson Nirnroot focus on maintaining the plant's unique genetic diversity while preserving the specialized characteristics that enable its integration with Dwemer technology. These programs employ advanced genetic sampling and storage techniques while recognizing that conventional genetic preservation methods may not adequately capture the quantum biological processes that appear essential to the plant's nature. The development of appropriate genetic preservation techniques for quantum biological systems represents pioneering work that may prove valuable for conserving other species with similar characteristics. The seed banking efforts for Crimson Nirnroot have encountered unique challenges related to the plant's quantum biological properties and its dependence upon specific technological environments for successful germination and growth. Conventional seed storage techniques prove inadequate for maintaining the viability of Crimson Nirnroot seeds, which appear to require continuous exposure to specific types of magical fields and acoustic environments to preserve their essential characteristics. The development of specialized seed storage facilities that can maintain these requirements represents significant advances in botanical preservation technology. The propagation research conducted with Crimson Nirnroot has revealed complex reproductive strategies that depend upon environmental cues generated by functioning Dwemer technology rather than conventional seasonal or climatic triggers. The plant's reproductive cycles appear to be synchronized with long-term operational patterns of technological systems, creating reproductive timing that operates on scales far exceeding those of conventional botanical species. Understanding these reproductive patterns has proven essential for developing successful conservation strategies, while providing insights into the long-term operational characteristics of Dwemer technology. The pollination mechanisms employed by Crimson Nirnroot demonstrate remarkable adaptations to underground environments that lack conventional pollinators, while maintaining genetic diversity through sophisticated biological and technological interfaces. The plant appears to employ both conventional reproductive strategies and novel approaches that utilize technological systems for genetic material transfer between distant populations. These hybrid reproductive strategies ensure genetic diversity while accommodating the unique constraints of underground environments that lack most conventional pollinators. The dispersal patterns of Crimson Nirnroot seeds reveal complex relationships between plant reproduction and the operational status of technological systems throughout Blackreach. Seeds appear to be distributed through technological networks that transport them to suitable growing locations based on environmental conditions, monitored by Dwemer systems. This technologically mediated seed dispersal creates distribution patterns that optimize genetic diversity, while ensuring that new populations establish in locations with appropriate technological support for continued growth and development. The population genetics of Crimson Nirnroot reveal patterns of genetic diversity that suggest both natural evolutionary processes and deliberate genetic management by the plant's original creators. The genetic structure of current populations shows evidence of careful breeding programs that maintained desired characteristics while preventing inbreeding depression that might result from small population sizes isolated in underground environments. These genetic patterns suggest that the Dwemer employed sophisticated genetic management techniques to ensure long-term viability of their biotechnological creations. The hybridization potential between Crimson Nirnroot and related surface species has generated interest as a possible avenue for expanding the plant's habitat range while preserving its essential characteristics. Research into hybrid development has encountered significant challenges related to the fundamental genetic differences between Crimson Nirnroot and conventional plant species. The quantum biological processes that characterize Crimson Nirnroot appear to be incompatible with conventional plant genetics, preventing successful hybridization through normal reproductive mechanisms. The adaptation studies conducted with Crimson Nirnroot populations in different areas of Blackreach have revealed remarkable flexibility in the plant's response to varying environmental conditions, while maintaining its essential dependence upon technological integration. Plants growing in areas with different types of Dwemer installations demonstrate corresponding variations in their growth patterns and biochemical composition, suggesting that the species can adapt to different technological environments while preserving its fundamental characteristics. These adaptation capabilities provide hope for conservation efforts while demonstrating the sophisticated biological engineering that created the species. The climate change implications for Crimson Nirnroot conservation extend beyond conventional environmental concerns to encompass the stability of underground technological systems that maintain suitable growing conditions. Changes in surface climate patterns may affect groundwater flows and thermal regulation systems that contribute to maintaining optimal conditions in Blackreach environments. These indirect climate effects create additional conservation challenges that require monitoring and management of technological systems, in addition to conventional biological conservation approaches. The restoration ecology approaches developed for Crimson Nirnroot habitats integrate biological restoration techniques with technological archaeology to create comprehensive habitat management strategies. These approaches recognize that successful habitat restoration requires maintaining both suitable biological conditions and functional technological support systems. The integration of biological and technological restoration represents innovative approaches to conservation that may prove valuable for preserving other species with similar technological dependencies. The ecosystem services provided by Crimson Nirnroot extend far beyond its immediate biological functions to encompass roles in maintaining the stability and functionality of entire underground ecosystems. The plant serves as a keystone species that facilitates communication and resource sharing among diverse biological communities, while also serving as an interface between biological systems and technological infrastructure. These ecosystem services make Crimson Nirnroot conservation essential for maintaining the ecological integrity of Blackreach environments, regardless of its direct applications for human purposes. The economic valuation of Crimson Nirnroot ecosystem services reveals values that far exceed those based solely on direct applications of the plant for alchemical or consciousness enhancement purposes. The plant's role in maintaining technological systems that support entire underground ecosystems creates economic values that include the preservation of unique biological resources, the maintenance of technological artifacts with immense historical and scientific value, and the continuation of natural processes that may prove essential for future technological development. These broader economic considerations provide additional justification for conservation efforts, while highlighting the interconnected nature of biological and technological preservation. The cultural preservation aspects of Crimson Nirnroot conservation encompass not only the plant itself, but also the traditional knowledge and practices associated with its study and application. The loss of Crimson Nirnroot populations would eliminate opportunities for future generations to develop understanding of quantum biological consciousness enhancement and biotechnological integration. These cultural preservation concerns extend beyond immediate scientific interests to encompass broader questions about humanity's relationship with consciousness enhancement and technological integration. The educational value of Crimson Nirnroot as a living example of biotechnological integration makes its preservation essential for advancing understanding of consciousness, technology, and their potential synthesis. The plant provides unique opportunities for students and researchers to observe and interact with systems that transcend conventional boundaries between biological and technological phenomena. These educational applications may prove crucial for developing the knowledge and skills necessary for creating future biotechnological systems that can benefit human civilization while maintaining ecological sustainability. The inspirational impact of Crimson Nirnroot discoveries extends throughout multiple fields of human endeavor, from scientific research to technological development to consciousness exploration. The plant demonstrates possibilities for existence that transcend current limitations, while providing practical pathways for achieving enhanced capabilities through cooperation with biological systems. These inspirational aspects may prove as valuable as any direct applications, motivating continued exploration and development of biotechnological integration approaches that could transform human civilization in fundamental ways. The legacy considerations surrounding Crimson Nirnroot preservation encompass responsibilities to future generations who may develop capabilities for utilizing the plant's potential in ways that remain beyond current imagination. The preservation of Crimson Nirnroot populations ensures that future human civilizations will have access to quantum biological consciousness enhancement technologies that may prove essential for addressing challenges that have not yet emerged. These legacy responsibilities create moral imperatives for conservation that extend far beyond immediate practical considerations to encompass long-term human development possibilities. The interdisciplinary cooperation required for effective Crimson Nirnroot conservation has created new models for collaborative research and preservation efforts that integrate expertise from diverse fields, including botany, archaeology, consciousness studies, quantum physics, and magical theory. These collaborative approaches demonstrate possibilities for addressing complex conservation challenges through integrated efforts that transcend traditional academic and professional boundaries. The success of these collaborative models may prove valuable for addressing other complex challenges that require interdisciplinary cooperation and integrated approaches to problem solving. The international coordination necessary for Crimson Nirnroot conservation efforts has stimulated development of new frameworks for managing shared resources that exist in unique environments with complex access requirements. The limited availability of Blackreach environments and the specialized expertise required for working with Crimson Nirnroot create needs for international cooperation that balance different national interests while ensuring effective conservation outcomes. These coordination frameworks may prove valuable for managing other unique resources that require international cooperation for effective preservation and utilization. The technological development stimulated by Crimson Nirnroot research has created innovations that extend far beyond immediate conservation applications to encompass advances in quantum biology, consciousness interface technology, and biotechnological integration systems. The challenges presented by studying and preserving Crimson Nirnroot have motivated development of new research tools and techniques that prove valuable for addressing other complex scientific and technological challenges. These technological spillover effects multiply the value of Crimson Nirnroot research, while demonstrating how conservation efforts can stimulate broader technological advancement. The philosophical implications of Crimson Nirnroot conservation extend beyond practical considerations to encompass fundamental questions about humanity's relationship with consciousness enhancement and biotechnological integration. The plant represents possibilities for human development that challenge conventional understanding of individual identity and cognitive limitation, while raising questions about the appropriate direction for human evolution. These philosophical considerations require careful thought about the values and principles that should guide conservation efforts, while ensuring that preservation activities remain aligned with broader human interests and ethical considerations. The mystery that continues to surround Crimson Nirnroot ensures that its study will remain a frontier for exploration and discovery, regardless of current understanding and conservation efforts. Each new insight into the plant's nature reveals additional layers of complexity that suggest depths of understanding that may require generations of continued research to fully explore. This ongoing mystery makes Crimson Nirnroot preservation essential, not only for current applications, but also for ensuring that future researchers will have access to phenomena that may prove central to understanding consciousness, technology, and their potential integration in ways that remain beyond current imagination.